In today's video, we are going to look at this bracket that we need to expand. We know that when we have a bracket like this and raised to the power 2, it is very easy to expand. Suppose we have, let's replace the 4 by 2. We know that this we take x, we raise it to the power 2, and then plus we take 2x, we multiply by 2 to get 4x, and then the 2 to the power 2 we get 4. That is very easy to work out. But when we have the power starting from 3 going to 4 or 5, it becomes a little bit difficult. Now because of that, then we can now use what is known as binomial expansion theorem. But we are not going to go deep into that. What I want to introduce to you is what people call Pascal's triangle to expand that. Now the Pascal's triangle, we start with 1 and then followed by 1 on the other sides like that, and then this side we should also have 1, and then 1 plus 1 we get 2 in the middle here, and then the other side we get 1. We started with 1 term, 2 terms, 3 terms. Now we should have 4 terms, but on the sides we should have 1, and then to get the second term we add this, we get 3. We also add these 2, we get 3, and then this side we should have 1. Now therefore we have to find the fifth term. We write 1 here, and then 1 plus 3 is 4, and then 3 plus 3 is 6, 3 plus 1 is 4, and then 1 at the end. We can also go ahead and then we write 1 here. 1 plus 4 we get 5, 4 plus 6 we get 10, 6 plus 4 we get 10, 4 plus 1 we get 5, and then 1 at the end again. Now since we have our bracket which is raised to the power 4, we need 4 rows. Now this is how we do it. This is row 1, this is row 2, this is row 0, sorry, this is row 1, this is row 2, this is row 3, and then this is row 4, and then this is row 5. Now since our bracket is raised to the power 4, we need this row here. So what is going to happen now? Let me rewrite that bracket there. We have x plus 2 raised to the power 4. Now when we use the Pascal's triangle, it becomes very easy to expand this bracket. So what we need is these numbers in row 4. So let's write them. 1 here, and then we can write the other number which is 4 somewhere here, and then 6 somewhere there. You see why I'm leaving so much space in between, and then the other number which is 4 somewhere there, and then 1 at the end. Now in between here, we have to use the variable and the constant. Now this is how to go about it. The x should be raised to the power 4, while the 2 should be raised to the power 0. We are multiplying these two. We're also multiplying by that one. And then we say plus here. Now keep in mind, we are interested in the powers. 4 plus 0 gives us 4. Here, the x should be reduced by 1. The power should be reduced by 1, meaning we're going to have x to the power 3, while the 2 should be increased by 1 to the power 1, from 0 to 1. And then plus, we are still multiplying here. The x should be reduced, the x power should be reduced by 1 to have 2, while the 2 should be increased by 1 to get 2. And then plus, we have 4 there, and then we multiply by x. The power should be reduced by 1 to get 1. The power here at 2 should be increased by 1 so that we can have 3. And then plus, the x here should be reduced by 1 so that we can have x to the power 0. And then the 2 should be increased by 1 to have 4. Now keep in mind that the exponents of x and 2 should add up to 4. 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. 0 plus 4 is 4. Now we can go ahead and work out or simplify. Anything multiplied by 1 is just we get the same thing. Anything to the power 0 is 1. So this side we are going to have x to the power 4 plus, we write our 4, this 4 here, times 2 to the power 1 is just 2. X to the power 3, we just leave it like that. Plus, we write our 6 times 2 to the power 2 is 4. While the x, we leave it the way it is. Plus, we write our 4 and then times 2 to the power 3 is 8. And our x, we leave it the way it is. We don't need to write the 1. Although here we wrote the 1, but for the explanation purpose here we don't need to write the 1. And then plus 1 times 2 to the power 4. 2 to the power 4 is 16 times 1 is just 16. X to the power 0 is 1 times 1, and then you multiply by 16, just the same thing. So we are not really bothered about that. Now coming down here, on this side we have x to the power 4 plus 4 times 2, we should get 8, and then x cube plus 6 times 4, we should get 24, and then the x be squared plus 4 times 8 is 32, and then we have x there, and then plus 16. So this is the answer to that bracket. If you want to confirm this answer, what you can do, since we know from the beginning that this bracket can be written in that form, you can try to multiply this bracket by itself twice. We can try to do that. You can see we have 3 terms there. So you are going to have so many terms, but when you simplify them, you should get to this answer. This is the reason why a binomial expansion theorem comes in, so that we can use this Pascal's triangle to give us the coefficients of the variable and the constant that we have inside the bracket, and then we can now work out, and then we simplify to get the the the, the answer that we need. In the next video I will touch on a bracket like 1 plus, let's say, x over 2, for example, to the power, let's say, half. In the next video I want to focus on something like that. Now keep in mind, the binomial expansion theorem, working with the triangle, you can see the exponent here is negative. Now the binomial expansion theorem, especially when you are using the Pascal's triangle, this only works if the exponent is positive. What we have just done here, only if the exponent is positive. Now in the case when the exponent is negative, there is a formula for that, and I'll give you the formula in the next video when we are going to solve this bracket.